So welcome to this segment as we look at specific heat capacity. Before we start looking at specific heat capacity, I want just to give you a scenario. You could imagine that you go to the beach. So when you go to the beach, oftentimes you are going to find that there's sand, and you have got water in the sea. So water in the sea that is available. Now, of course, when you look at both the sand and the water, if sunlight is there, the sun is simply going to heat up the sand and the water at the same time, period. However, which of the two is going to get hotter very quickly? Of course, the sand is going to get very hot quickly as compared to the water in the sea, because the water in the sea gets hot very slowly. Now, why the difference? Well, this can be explained in terms of what we simply call as being heat capacity. So it can be explained in terms of heat capacity. And one thing that you need to remember is that different objects have different heat capacity. In this case, sand has a low heat capacity, while water in the sea has got a high heat capacity. So because sand has a low heat capacity, no wonder it quickly gets hot. But water that is in the sea has a high heat capacity, and hence it gets hot very slowly. Now we want to define this word before we move on. Heat capacity. What exactly is heat capacity? But let's start with that one, because that's the key concept that you need to remember. So when we talk about heat capacity, what is it? In most cases, we use a capital letter C to represent heat capacity. So heat capacity of an object is simply the quantity of heat needed to raise the temperature of the object by 1 degree Celsius. So I'm simply saying heat capacity, of an object, we can say of an object is the quantity, so is the quantity of heat needed to raise the temperature of the object by 1 degrees. That is what we mean. So this is what we call as being heat capacity. So it's just the quantity of heat needed to raise the temperature of an object by 1 degrees. That is what we call as being the heat capacity. And therefore, if you want to find the heat capacity, the formula that you can apply is that when it comes to heat capacity, so let me say when it comes to heat capacity, capital letter C, it is equal to, in this case, the quantity of, let me just say the quantity of heat supplied, so the quantity of heat that has been supplied divided in this case by the change in temperature. So the quantity of heat that is supplied divided by the heat by the change in temperature. So we can say specific heat capacity, capital letter C, the quantity of heat that is actually supplied. We can use, like I told you, some books are going to be using Q, or others are going to be using E. It doesn't matter. So in this case, I will be using E in this case. So the quantity of heat that has been supplied, or the energy of heat that has been supplied, divided by the change in temperature, represented by delta theta there. So that is what you need to remember. Now if you look at it this way, energy is measured in joules, and when you look at temperature here, the SI unit, yes, that we know in this case can be in Kelvin. That is what we know, that's the SI unit, so it can be joule per Kelvin. But sometimes it is also true that you can also express it as energy divided by change in temperature. You can also say joule divided by degrees Celsius, and that will give you joule per degree Celsius. So whether they use all that, is simply just going to be the same Right. Now I want you to understand that when it comes to changes, as we are going to look at, the change in Kelvin and in degree, they are just the same. So no wonder sometimes you can actually use Kelvin or you can use degrees, because the change in temperature is just going to be the same. So you don't need, actually to be alarmed by that. So you can either use this or that. So like I said, when it comes to the unit, in this case for heat capacity, that you need to remember, the unit for heat capacity is simply joule per degree Celsius. So you can also write it like that, there's no problem. Yeah, or joule per Kelvin is just the same. Do not be alarmed by that. But like we said, when we talk about different objects, they have got different heat capacity. Let me just demonstrate it this way. Let's say that you have got 100 joules of heat that is actually supplied, so you have got 100 joules of heat, that is actually supplied to two objects. And let me say I've got object X, and I also have object Y. But to each of these, object X and object Y, you are supplying 100 joules of heat, energy is actually being supplied. Well, of course, let's say that object X experiences a rise in temperature by just 1 degree Celsius. So let's say it experiences a rise in temperature just by 1 degree Celsius. And let's say that object Y, experiences a rise in temperature by 2 degrees, Celsius. What are the respective heat capacity? Suppose I told you to say, find capital C. What would be for both of these guys? What would be the, heat capacity that they are going to have? Okay, we can actually work out that. Yes, the heat capacity in this case for object X, let me say Cx, it is going to be, remember, the energy that is supplied, which is 100 joules, divided by the change in temperature, which is 1 degree. This is going to give me 100 joules per degree Celsius. That would be the heat capacity. What about in this case for object X? Remember, they were given the same amount of energy, but this object had a rise in temperature by 2 degrees. So what would be the heat capacity for object Y? It is going to be the same energy divided by the change in temperature, which is 2 degrees Celsius. So now when you look at this one, it will give you 50 joules per degree Celsius. So that is going to be the heat capacity for object Y. Now what's the conclusion that we can actually make from this analysis that we have done? Well, you can see that object X has a high specific heat capacity than Y. So object X has a high specific as a high let me say heat capacity. So it has a high heat capacity than object Y. That is what you can see from what we have actually gotten there. What else can we therefore conclude relating to this example that I've given you? It simply means therefore that the increase in temperature of object X is less than object Y. So if something has got a high heat capacity, it simply means that the increase in temperature is actually less as compared to the one with a low heat capacity. So that is the whole idea that we can have. So I can simply say, therefore the increase in temperature, so I can say the increase in temperature of object X is less than object Y. Why? Remember that X has a high heat capacity, has a high heat capacity than object Y. So that is the conclusion that you need to remember. So now, in summary, when I talk about heat capacity, heat capacity, I can simply say, this is, let me call it as being a golden tip that you people need to remember. It simply means that, heat capacity of an object increases when the mass of an object increases. Very important that you get that. So I'm simply saying that heat capacity of an object, so heat capacity of an object increases when the mass of the object increases. So when the mass of the object increases, it simply means that the heat capacity also increases. It's like heat capacity is directly proportional to the mass. That's what we mean. So increasing the mass increases what we are calling as being the heat capacity. So even if you increase the heat capacity, it simply means it has a bigger mass. And how can we know that this is actually very true? Well, what you can do is that you can try to compare, for example, maybe we can say we put water, in a full kettle. If you put water in a full kettle, and you also put water, in a half filled kettle. So you put water in a half-filled kettle. Which one do you think is actually going to take longer? Water in a full kettle, you put water full in a kettle, or you put water half in a kettle and you try to heat them to boil? Which one is going to take longer to boil? Obviously, you know the answer. The water that you have filled up in the kettle is actually going to take longer as compared to the half-filled kettle. This one will actually boil much faster. So that is why we are simply saying that water of big mass has a high heat capacity compared to water of smaller mass. So that is what you need to remember. Now this brings us now to the discussion there, which is a very important now discussion. In your exam, you're going to find that they'll tell you to define now a specific heat capacity. Specific heat capacity. What exactly is specific heat capacity? So specific heat capacity is represented by a lowercase letter. In other words, it is represented by a small letter c. What exactly is the specific heat capacity? So when we talk about specific heat capacity of a substance, it is simply the quantity of heat needed to raise the temperature of a unit mass, or if you want a 1 kg mass of the substance, by just 1 degree. So if you have got a substance, a 1 kg mass, what amount of energy is needed to raise the temperature of this 1 kg or unit mass of a substance just by 1 degree, or if you want, you can say by 1 Kelvin. What energy? So that's what we simply call as being specific. And each time we use the word specific, we are going to be using a unit mass or 1 kg because we are being specific. So I can simply say specific heat capacity of a substance. Specific heat capacity of a substance is the quantity, so we can say is the quantity of heat needed to raise the temperature. So needed to raise the temperature of a unit mass, that is 1 kg, that's what we mean, of the substance, by 1 degree Celsius. Or if you want, you can say just by 1 Kelvin. So that is what we mean. So this is what we call specific heat capacity. So remember, it is simply the quantity of heat needed to raise the temperature of a unit mass just by 1 degree or 1 Kelvin. Therefore, what is the formula that we need to apply when it comes to this one? Well, the formula that you can use in this case is that specific heat capacity, small letter c, remember, is simply the thermal energy divided in this case by the mass multiplied by the change in temperature, where in this case we mean the E is representing the quantity of heat the quantity of heat that has been supplied, and that is measured in joules. Remember, M is representing the mass, and you know the mass is supposed to be in kg, and delta, in this case delta theta there is representing, you know, change in temperature. So that is representing change in temperature. It could either be in degrees Celsius or it could be in Kelvin. That is what you need to remember. So what is the SI unit in this case for specific heat capacity? Well, let's try to you know, give you this. Let's try to rewrite the formula. Remember, specific heat capacity, energy over mass and change in temperature. So specific energy is measured, remember, in joule, and mass is in kilogram. And when you look at when we look at change in temperature, it could be in degrees Celsius. So combining that will give you joule per Kelvin, you know, degrees Celsius. Like I said, you could also, in this case, you know, you could also be finding it there, putting up Kelvin. It's just the same. So it could be joules, you know, the mass in kg and the Kelvin. So it would be joule per kg Kelvin. So that is what, you know, you can use. So I can simply say in summary that unit, in this case, unit for specific heat capacity represented by small letter c is simply equal to, we can simply say it is joule per kg degrees Celsius, or you can use joule per kg, you know, Kelvin. So remember, these are just the same. You shouldn't be confusing them. So that is what you need to remember. Now suppose I want to know the quantity of heat that is absorbed or released by an object. What formula can I use? Well, if you want to know and determine the quantity of you know, heat E that is absorbed, because remember, energy can be absorbed or released by an object. So if you want to know the quantity of heat that is absorbed or released by an object, it can actually be determined by the formula. We just need to make E the subject of the formula. I can say over 1 cross multiply, so the energy will be equal to mass, specific heat capacity, times the change in water, times the change in temperature. So this is what you can use if you want to know the energy that is absorbed or released. Now I want you to be particularly sure when it comes to this one. Different materials have got you know, different specific heat capacity. There are tables, certain books have got tables of certain specific heat capacities of different substances, either be it you know, solids, liquids, or be it you know, non-metals. You can actually find those in books, and they'll be giving you those things in the exam. But it's always good to know for some, like water, you know, you just need to know in this case. Now let me tell you an example. Let's say, for example, the specific heat capacity of a metal. Let's say you know, the specific heat capacity, let me say that the specific, you know, heat capacity, the specific heat capacity of a metal, you know, aluminium. Let's say the specific heat capacity of a metal aluminium is 900. Let's say it is 900 joule per kg degrees Celsius. What does that mean when they tell you the specific heat capacity is 900 joule per kg degrees Celsius? Well, this simply means that you know, this means that you know, 1 kg of aluminium, you know, requires, it means that 1 kg of aluminium requires 900 joules of energy in order for you to raise, you know, the temperature by 1 degree Celsius. That's what it simply means. It simply means that 1 kg of aluminium requires this amount of energy for you to raise the temperature by just 1 degree Celsius. That is what this value simply tells you, the specific heat capacity. Now, in summary, I don't want you to confuse heat capacity and what we are calling as being specific heat capacity. Remember, in summary, let me just try to summarize for you. So in summary, you know, when I talk about heat capacity, you know, capital C, it is simply the energy divided by the change in temperature. Hope you remember that. And the second one, when I talk about you know, the specific, you know, heat capacity, when I talk about specific heat capacity represented by small letter c, it is simply the energy divided by the mass and the change in temperature. You should be able to remember that. So remember, this is the quantity of heat energy needed to change the temperature of a substance by 1 degree. But this one here, it is the quantity of heat that is needed to change, you know, the 1 kg or a unit mass by 1 degree Celsius. But here, yes, you are trying to raise it by 1 degree Celsius, but here you are trying to change specifically a 1 kg mass by raising its temperature by 1 degree. That's specific. No wonder we are using the word specific. So watch out for you know, some other, you know, questions. I'll do some you know, tutorial questions so that I can show you how you can use, you know, these formulas to do some calculations in my next video. Thank you so much for watching.